Welcome back. Today, we are diving deep into a powerful and often overlooked SQL concepts called self-joins. Tired of writing complex subqueries, struggling to analyze hierarchical data like organizational structure or parent-child relationship? Self-joins are your secret weapon. In this video, we will break down exactly what self-joins are, when and why you would use them, and most importantly, how to implement them effectively in SQL Server. By the end of this video, you will be able to simplify your SQL code by eliminating those messy subqueries and write cleaner, more effective queries. Unlock insight from hierarchical data by easily analyzing organizational structure, family trees, and any data with self-referencing relationships. And boost your SQL skills, impress your colleagues, and land that dream data analyst role or other roles as a wish. So grab your favorite beverage, get ready to level up your SQL game, and let's explore the power of self-joins together. Let's first define self-join. Self-join is a join where the table is joins to itself. So you may have a kind of data wherein the data stored in the same table needs to be joined for some purpose. And we are going to explore those. And this basically allows to compare the interrelated rows within the same table. Talking about this example, we have C1 employee table, which has got employee ID, employee name, date of birth, employee address, and this employee is reporting to some manager, so manager ID is in front. This is a single table which contains the data of employee as well as their managers as well. So let's say, for example, Babin Toddy reports to 1005, which is Dino Jason. So Dino Jason's and Babin Toddy's both details are in the same table. So I am in requirement wherein I wanted to visualize that the employees and their respective manager names. So for this, we do not need two tables because all the data related to the employee and their manager sit in the same table. So we'll do some mechanism as we have just studied the self-join to join table by itself. We will achieve this and we can get data like this. How beautiful this data looks like. Babin Toddy reports to Dino. Neha Sharma reports to Dino. Sumit Thakkar reports to Tony Simon. You see that Sumit Thakkar, he reports to 1004, which is Tony Simon. So you have seen that the single table has been used to extract data, and the kind of techniques that we have used is a self-join here. Let's go and explore some real-time use cases of self-join. The first case is employee-manager relationship, which we have already seen in the last snap. So we have this employee table, and I wanted to visualize that which employee reports to the particular manager, both the data in the same table. So I'll put a self-join to this table and I'll extract the details like this. So you see that Babin Toddy reports to Dino, Neha Sharma reports to Dino, Sumit Thakkar reports to Tony, and Tony also reports to Dino, right? So this way, this is one of the mostly used use cases of self-join. Going for the next one. Case 2 is the product category subcategories. So I have one table which contains product details, and this is a table you see. So this is a category ID 1, which is for electronics, category ID 2, which is for laptops, category ID 3, which is for smartphones. But these categories also belong to some parent category. For example, let's say laptops. So what are laptops? Laptops are of electronics category. So you see that electronics is also the part of the same table, but I wanted to visualize in such a way that the product and which category they belong to, right? So for that, I can use a self-join here. You see that laptop belongs to electronics category, smartphones belongs to electronics category, accessories belongs to laptop, chargers belong to accessories, and screen guards also belong to accessories. So this way, this is one of the use cases of self-join out here. Okay, to take the third example of the self-join, team hierarchy in the project. So we have project teams, whether it is a software project team or others, they have a hierarchy. The hierarchy is one person is belonging to some team and the team has got a team lead. The team lead is the one who manages the other team members. So the data is like this. We have member ID or team member ID. We have team member name, and he reports to or she reports to some lead, or he or she is under some team lead. So this has got a lead ID. So this is a single table which contains all data. What I want to do is I want to visualize this data in such a way so that I want to see the team member's name and the name of the team lead. So I will put a self join out here, and these details can be retrieved this way. So you see that Sarah reports to John Matthew, or Sarah is under the team of John Matthew. Dino Jason is under the team of Sarah. That means the Sarah is the team lead for Dino Jason. Likewise, Sarah is the team lead for Terry Lee, right? So this way we can analyze such data using self join. Make sense? Let's go and try some other use cases. So we can have n number of use cases. The 3 use cases I have explained you with example. Now we can have peer review system. So in project, especially in software industry, you have a what you call review system. So you write some code and your code is to be reviewed by somebody, correct? So that review, the person who reviews your code is called reviewer, and this is how we visualize that peer review system. So you are a developer, you have written a code, it will be reviewed by your reviewer. So there is a table which contains all peer and reviewers details, and you wanted to visualize that who is the reviewer for, what is the reviewer name for which peer, so that you can visualize. So this is again can be done by self join. Organizational structure. So you have an organization which has got one employee reporting to some other, he reports to somebody else or she reports to somebody else. So likewise, this hierarchy or organizational structure can be visualized using self join. You have a family tree, you have parent, grandparent, parents, kids, children. So these things, grandchildren, this can be analyzed and visualized using self join. So we have seen ample example which depict that self joins are quite important, and they can be used for many purposes out there. This is the way that you write a self join. You see this is a single table, TVL employee, and I'm doing a left outer join to TVL employee itself. 2 aliases are written, E and M, and then I'm telling that E.manager ID, the first table's manager ID should be equal to the second table's, which is the first, this is the same table only, second table's employee ID. And this way I can display the data like user ID and username, and at the side of that username, the person, the manager's name, right? Why should we use? There are some cases like if you have hierarchical data wherein you have hierarchy, so you should use to analyze that self join. You have data analysis to be done in the same table, self join is the option. You have real world relevance like HR systems, e-commerce catalogs, and social networks. We have seen all those examples. Self join can be most suitable out there. Having said that, we have understood the self join concept, the use cases of self join, and how to write self join. Let's go and see these all in action. I'm going to take you to SQL Server Management Studio and show these all in action. So let's go there. So I am in SQL Server Management Studio, and I have written a couple of scripts for you to execute them quickly so that we both can save our time and video won't be too longer. So this is the first script written for creating one TVL employee. This has got a couple of fields called employee ID, employee name, employee date of birth, employee address, and manager ID. This particular employee who reports to this manager. Let's create this table. The table gets created, and then let's insert a couple of records to this table. The records got inserted. Now let's visualize this data in this table. I am selecting these all data. So you see this particular table gets displayed. Employee ID this, employee name this, employee date of birth, and the address, and then manager ID that belongs to. Now I'm going to be in a requirement where I want to show the employee name along with their manager name. So I wanted to introduce self join here. I can add the self join out here. So you see that employee name from M, and there are two aliases, TVL employee E, TVL employee M, and on E, I'm going to do left outer join by M. Okay, so it will show all from left, but if nothing there in the right, so it will show that as a null, right? And E.manager ID, M.manager ID. So let's go and execute this. I'm going to execute this. You see that Babin D reports to denotation, Neha Sharma reports to denotation. So we can see that expected result out here. This is the first example. The second example is about product and category. So for this, I have created one product category table, product ID, category ID, category name, and which parent category it belongs to. Let's go create this table. The table has been created. Let's insert the data to this table. Data has been inserted. Let's go and visualize this self join as well as select statement. So the select statement is first is electronics, and this is parent ID is null. And second is laptop, its parent ID is 1. So you see that laptop belongs to 1, that is electronics. And in this way, you can actually visualize the data on the self table. Let's go and explore the third table. The third example is the team hierarchy. I have a team, I have the members in the team and a couple of team leads. So who all are the members under which team lead that we want to visualize? So let's go and create the tables. This is member ID, member name, and lead ID. The lead ID is the ID whom this member reports to, or under whom this particular member works. So let's go and create this table. Table has been created. Let's go insert a couple of records to this table. Records have been inserted, and then I have a SQL select statement as well as that self join that I have written on this table. So let's go select both of them to execute, and then see that the member ID 1 is John Matthew. He has no lead assigned, but number 2 is Sarah, who has lead ID 1 assigned. So lead ID 1 is what? John Matthew. So you see here, Sarah has been assigned John Matthew. Like Mike Pompeo has been assigned one lead called 1. 1 is what? John Matthew. So you see Mike Pompeo, John. So this way you can visualize the data. Having said that, we have explained the concept of self-join, and with the many examples, I think you are all well aware of this fact now, and you would be able to use this in our projects, in real-time projects. If you found this video helpful, don't forget to hit that like button and subscribe for more high-quality technical content. Also press the bell icon. Drop your question in comment, and I will be happy to answer them. See you in the next one. Bye-bye.